So in these problems, we're going to be looking at optimization. And optimization is a pretty common topic in calculus. And like related rates, the biggest part is to make sure you set it up. And then we're going to use our techniques to maximize or minimize a given function using the first derivative test or second derivative test. So that's the general idea. So here's find the maximum product of two numbers that have a sum of 100. My first is a setup is to just say like, okay, the product is equal to two numbers. We'll say x times y. And then they have a sum of 100. So that means like of my two numbers, I know that they have to add up to 100. Now, in calculus that we've learned so far, the way to maximize a function is I need to put it into terms of one variable. I can't do these derivatives with more than one variable. Like I don't know how to maximize or minimize that. That is for multivariable calculus, which is later in your career if you continue down math. So in this case, to make this a function, this is really a function, p of x. Okay, or p of x and y at this case. To make this a single function of x, I can solve for y. Y is 100 minus x. And so this is going to be x times 100 minus x. Or I can distribute and get 100x minus x squared. Okay, so now this is good. Now I have a function I can maximize. And I'm going to attempt to figure out what the maximum value is. Now, to do that, I'm going to take the derivative. So I'm going to take the derivative of this. It's going to be 100 minus 2x equals 0. This is how I find my critical numbers, right? That's how I find the maximum of a graph of a function. First, I find the critical numbers. This would be x is equal to 50, as you can see. Okay, now we have to determine is this our minimum or maximum. Well, I can use the second derivative test to tell me that this is equal to -2. This is less than 0. This is a maximum because it's concave down. So I mean x equals 50 is my answer. That also means my other number is y is also equal to 50 because they add up to 100. And so that would give me the maximum product. Oh, they actually wanted the maximum product, and the p would be 2500 in this case. 50 times 50. Okay. Here's find the maximum sum of two positive numbers. So I want to maximize the sum whose product is equal to 500. And so by the same thing, I want to say this is y is equal to 500 over x. I need to get this in terms of one variable. So this is x plus 500 over x, right? And so s prime, the first derivative is going to be 1. And then 500 x to the -1. The derivative of that would be -500 x to the -2, which is equal to -500 over x squared. So this is going to be 1 minus 500 over x squared is equal to 0. So I rearrange this. That gives me x squared is equal to 500. So x is equal to plus or minus the square root of 500. But because this is telling us two positive numbers, I only want the positive number. So this is going to be x is equal to, I can take out 100, so it's 10 root 5. Okay. Now I want to know if this is a positive, is this a maximum or a minimum here? You can think of it intuitively as to say like, well, it would probably be a maximum because like the minimum would be like if this is like 0, then the sum would be like 500. Well, I don't know actually. So let's actually compute this. So I could do second derivative test. So the second derivative test, looking at it from this form, it's going to be -500 times -2 x to the -3, and that's equal to 1000. The positive because the negatives cancels over x cubed. This is greater than 0, so this is going to be a minimum. Okay. So, so what are the? So if this is a minimum, maximum sum of two products. This is a minimum. Yeah. So general this shape. I think it's not going to have a maximum because if I plotted this curve, when it's really small, it's going to go like down here, and then it's going to go like, oh, this function. So it's x, it's a line plus this. I'm trying to just get an idea of what kind of curve I'm looking at. But there doesn't appear to be a maximum because of the way the first derivative. Are there any other critical numbers to deal with? 0, but 0 is not a critical number, even though the derivative would be undefined there. We need 2 positive numbers whose product. I can't include 0 because 0 times anything is not going to be 500. Yeah, I think this makes sense. I don't know if this makes sense to you, but if x were a tiny number, like x was like 0.001, then y would have to be like 500, 1,000. And then this sum would be like 500,000 and 0.001, right? So to maximize this actually doesn't really make any sense. There's no maximum value because as long as x goes smaller and smaller and smaller, y is going to get bigger and bigger and bigger, and the sum's going to go to infinity. So there is no maximum. It can be any value. And so that's one reason why we sometimes have to check the first or second derivative. Because you might have said like, oh, I have one critical number, and so that should be my answer. But that's actually a minimum. Okay, so I don't know if it's a typo in the problem or if it's a kind of a trick question. Find the maximal area of a right triangle with hypotenuse of length 5. So I have a right triangle here, length 5, and we're going to say this is x and y. So the area is equal to 1/2 x times y, right? That's what I don't know. But again, I need to relate x and y so I can put this in terms of one variable, and I can use the Pythagorean theorem that this is true. So that means y, if I solve for it, has to be the square root of 25 minus x squared. And so then I'm going to plug that into here. The area is 1/2 x square root of 25 minus x squared. Okay, so to maximize, I need to find the critical numbers when the derivative is equal to 0. Bring out the 1/2, and I'm going to do product rule between these two functions. This is going to be x times the derivative of this. This I write as 25 minus x squared to the 1/2, so I can use my power and chain rule correctly. That's 1/2, 25 minus x squared. 1/2 minus 1 is negative 1/2. Times, but the inside's not x, so times the derivative of the inside, which would be negative 2x, plus, I brought this 1/2 out, plus the derivative of x, which is just 1, times 25 minus x squared to the 1/2, just the radical one there. Okay, and then I want to factor out, so this 1/2 and this 2 cancels. I want to factor out the largest term, the smallest term of 25 minus x squared. That's negative 1/2 because this is the smaller exponent. And so if I pull out here, I'm left with negative x squared plus, and then I think about what times this would give me this, just a 25 minus x squared to the 1 power, because 1 times negative 1/2 would make this positive 1/2. So this is 1/2 25 minus x squared to the negative 1/2 times 25 minus 2x squared. I got an x squared and another x squared subtracting. That has to equal 0. This is going to go in the denominator. So for this to equal 0, all that matters is this part. So 25 minus 2x squared is going to equal 0. And so 25 over 2 is equal to x squared. And so x is equal to plus or minus. We'll just make it plus. We use positive sides as positive 25 over 2, root 25 over 2. And that's 5 over root 2, which is 5 root 2 over 2. Okay? So that's what I got for that. Now I have to determine whether or not this is a maximum or minimum. Physically speaking, this is going to be a maximum because the minimum area, like if I made x really like 0, the area would be 0. So you could think intuitively that this is going to be the area. But let's just confirm that it is by looking at the first derivative. And I'm going to do the first derivative because the second derivative is kind of annoying, so I don't really want to do that. Okay, so this term's always positive down here because when you take the square root, it's always positive. This up here is going to be, if I'm bigger than 5 over root 2 and I square it, if this term is larger, it's going to be negative. And if it's smaller than root 5 over 2, it's going to be positive. So it's going to go from positive to negative. That makes it a maximum. So that's that. The y value would equal root 25 minus this squared, which would be 25 over 2. So that's also root 25 over 2. So x and y are equal, which should make sense. It's kind of symmetric. So the area is going to be equal to 1/2 root 25 over 2 times root 25 over 2. And that's 25 over 2, 25 over 4. Okay. Thanks for watching. If you're looking for more examples, go to my website. In there, I have free access to over 400 calculus questions that I solve and I show you step by step. So if you're interested in seeing more, please check out my website.